We're here to talk to you about Constraint Layout 2.0, a sneak peek. We'll be releasing this sometime within the next 2-3 weeks. So, okay, so here's Nicolas.
I heard there's another conference sometime in 2-3 weeks.
Yeah, who knows?
All right, but first, I'm going to talk a little bit about Constraint Layout 1.1 because that we did release last week. There's actually a Medium post that just got published today. Check it out. It goes into a little more details. I'm going to go relatively fast on 1.1 because I want to talk more about the 2.0 stuff. But essentially in 1.1, we added a couple of new constraint stuff, like the circular constraint, a couple of more helper objects, a new optimizer, and lots of bug fixes. You can grab it by adding this dependency in your Gradle file. It's very easy. If you're using 1.0.2, just replace the last two numbers and you should be good to go. All right, so I'm going to talk a little bit still about the barriers because that one, I think like with 1.0, we had a pretty good coverage in terms of what we wanted to expose in terms of concept for creating your layout. But there was one concept we were missing, and that concept is barriers. So essentially, that allows you to do something like that, right? When you have some widgets that whose dimensions are going to change, but you don't quite know which one is going to be the, like the widest in that example, but you do want to specify another widget relative to those ones. And essentially, that vertical bar that you see here, that's what we call a barrier. So how it works? Well, let's say I got like those 3 text views, and I'd like to position this image to the right of those text views. Whatever is the widest one. Essentially, you got the 3 views. Those ones you're going to be, you're going to put that into the barrier. And that 4th view, you're going to put it relative to the barrier. All the typical constraints apply, so it's just a normal connection to the barrier. And that allows you to do something like, well, if you have it like that, the widest one is the first one. If that changes, you see that things will position themselves correctly. So that's a very convenient tool to create more flexible UI like that. So if you haven't checked it, check it out. We got some support in the layout editor for it as well. So those options will only appear if you switch to Constraint Layout 1.1, but you will have the same way that the menu that lets you create guidelines will now let you create barriers as well. And I'm going to move on that because apparently we don't have time. Let me cover the optimizer, because that one, I think, we had an optimizer in 1.0, but the one in 1.1 is a lot better. We do a lot more optimization, and we also expose to you which optimization you want to enable or not. So essentially, how it works. We've got this concept of constraints. So we don't let you write linear equations by hand, because we are not mean. So we have this, this more higher level system of constraints to decide how you position your elements, your widgets. We then take those constraints, and you can imagine it as a big graph of dependencies. The position of this widget will depend on this other one, etc., etc. We run this graph of constraint into an optimizer, and whatever is left, we have to then measure, of course, the different widgets, and whatever is left of that, we put into the solver. And that's very powerful because that means that in a lot of situations where you don't really need a full-blown linear solver to figure out your layout, we don't even go to that last phase. And that's good because it's a pretty costly phase. But on the other hand, if you want very complex layout with really tricky behaviors, well, you still have the advantages of having the solver. So it's really kind of the best of both worlds. It's still relatively early in the type of situation we recognize and we optimize, but it's already a lot better than 1.0. And as time passes, we'll add a lot more optimization. So you should give it a try. So roughly how it works, you can imagine that you have here just a single widget, And that single widget is relative to some random position. That the idea here is that those circles are the nodes, if you want, of the constraint graph. So if I know the position of that one, I can directly derive the position of the other two. The last one because it's just the dimension of the widget, and the first one because it's a direct connection with a margin, for example. So you can take this idea and just propagate it on your graph. And essentially, as long as you got something that we can solve like that, we'll do it. So it's not, of course, it's not perfect. But you can then take something like a really complex constraint graph and solve a lot of those constraints. And it's still a big win because instead of having to consider this entire graph, we can just solve whatever is left. So in terms of the different categories of optimization we are exposing, we have a couple that are standard. We got the direct optimization, which is essentially what I just showed you in the previous slides, where I just have a widget that is constrained to the left of another widget, blah, 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 with a specific margin. That's very easy to solve. Barriers will be solved as well, as long as all the elements that are referenced by the barrier are already solved, essentially. But we've got two more that are not turned on by default, but you can try. One is chains. So chains is relatively costly. It's actually slightly more costly in 1.1 right now than it was in 1.0, mostly because we fixed a lot of issues, but that had a cost. So we added this optimizer that in a situation where it works, we don't even go to the solver. For now, we are just looking at the very basics of it. Essentially, if all the elements into the chains have a fixed dimension, then we don't need a solver. We can just solve it directly. Or if all the elements in the barrier have a match constraint, and I put like in brackets simple match constraint, because with 1.1 we did actually a lot of power, but in those situations we won't go into the optimizer. So give it a try, specifically because right now they are not turned on by default, and I would really like to turn them on. So the more people try it, the more we make sure that we are not forgetting any use cases. But they should work pretty well already. And the final one is the dimension optimizer. So this one is really new, so it might fail in more situations, but it has the potential to be really beneficial to your layout. So just to cover a little bit what it does, in general, one of the most costly parts in your layout is not so much the layout itself, than it is the individual measures of your elements, right? So specifically with text views and anything with text, it can be really costly. And we are trying to avoid as much as possible measuring many times the same element. But if you look at this table, so when everything is either fixed dimension or wrap content, which internally we kind of consider the same, you end up with a single measure. That's great. If everything is just match constraint, at least a simple match constraint case, again, we don't really care because that essentially means whatever is the final positions for the endpoints of my widgets, I'm just going to use that. So then essentially we don't measure the widget until we have solved the layout. So again, only one measure in that case, so that's great. The problem is the middle one, right? When you got one of the dimension is match constraint, the other one is wrap content. If it's fixed, actually I made a mistake. If it's fixed, we don't automatically need that, but the wrap content is really a problem. Because often the wrap content will depend on the other dimension. So what we end up doing is that we kind of prime the engine with doing one measure in wrap content, and then we solve, and then out of that we get new dimensions. We then have to remeasure, and out of that we might have to do another. So it can goes in a couple of layouts resolution like that. So that's not great. So essentially what this optimizer does, it tries to recognize this situation where your match constraint widget is connected to two endpoints that you do know the position, which actually is a very common scenario when you have, for instance, a layout where your element is in match constraint connected to the parent, and your parent itself is in match parent. So we know the size of the parent, so we know the final endpoints, So really, we know the size of the match constraint, and at this point, we can get by with a single constraint. And finally, here is how you can turn on this optimizer in your XML. Pretty straightforward. There is a new attribute, optimization level. If you use standard, it's just a mask of direct and barriers for now. Or in the future, we'll probably add more stuff as they kind of graduate to the level we want in standard. But otherwise, you can specify the extra ones, actions, and dimensions. And that's it for 1.1.
Okay. We'll talk to you a little bit about Constraint Layout 2.0. And first, kind of the big question, at least for us, is what are we going to put in it? Someone suggested coffee. That's a little bit too much. But we'll stop just short of that. But the real question is why? Why would we want to build Constraint Layout 2.0? What do we want to do with it? And the real problem that you developers are facing is UI is getting more and more complex. People want more sophistication, more animation, more subtle effects happening. It's becoming more and more difficult to develop a good, sophisticated UI. And so what we want to do is try and essentially provide you with better set of tools. We want to give you help. We want to try and come up with a system where the UI essentially expands its vocabulary. And you can think of the current layouts that we provide. When you set some stuff on it, you could think of it as sort of putting down nouns. We want to be able to add some sort of verbs to that now, where you get to create them, or you can find them on the web, that sort of thing. And the key way we're going to do that is helpers.
Right, so helpers is actually something you may know already, because that we're actually using this concept in Constraint Layout 1. And essentially, what is it? Well, it's something that's not necessarily part of your view hierarchy, but will be in your layout XML. It lets you specify or even be part of building your UI. And the typical example in Constraint Layout 1 is guideline. You know, if you never looked at that, it's pretty useful, specifically because it allows you to speak the same language as your designer, or barrier that we just covered. So we identified kind of 3 broad categories of helpers object like that. Maybe that will evolve, but so far what we think is some of them are going to deal with manipulating the layout. And I guess like guidelines or barriers might be more in this category. Some of them may do some manipulation once the layout has been done, and we'll cover a couple of examples. And finally, we think there is also scenarios where we could do some interesting and kind of fancy rendering approaches using this idea of helpers. So essentially, the helpers allows you to keep track of views. So you have a bunch of references of those views. You still keep a very flat, like a flat hierarchy for your layout. The key point is that those views can be referenced by multiple helpers, because it's not like a view group where once it's inside of your group, that's it. That's where it ends up in the hierarchy. Here, because the hierarchy itself is still flat, it's just a reference. And that suddenly is a lot of power, because you can think about those helpers like a way of tagging a behavior on your views. So in terms of the API that we'll expose in Constraint Layout 2, essentially with the constraint helper, we'll give you an access to a list of views that you can do something with. You'll have like pre and post layout callbacks that you can do something with. Don't forget that those are actually still normal views. So of course, if you don't want to do anything, you can just set them as gone and that's it, and forget about them. But you could also do something interesting, and that's what we use for the graphical parts of the helpers that we'll cover. And finally, and that we really think that's actually one of the important points, is that it's already kind of integrated with tooling. And of course, we want to build more on that. But really, the whole point of what we're trying to do here is that yes, UI and UI expectation from your users is getting increasingly, more complex, more rich. People want more powerful UI. And I think tooling here has a real important place, because this is how you can actually, be more efficient. Being able to really tackle those UI that, 20 years ago would have been insane to do, and now you can actually do. It's because of tooling and because of the frameworks, because of all those tools that we give to developers. So for the helpers, one powerful idea is that we kind of want to expose that to third-party libraries, essentially. So the ability of, as a third-party library, that you would be able to find whatever views or whatever helpers you define in your libraries could appear in the palette in Android Studio. So you could drag and drop your object, drag and drop your other helpers, and really take advantage of the existing infrastructure. So a quick example on how it works right now. If you try with 3.1 or 3.2 with helpers, so you can manipulate it essentially like you would do in the component tree with a view group. You can take those elements, drag them up into the view group, and sorry, not the view group, the helpers, and that's it. It really behaves the same way. The difference, though, is that because we only keep references, you can have those same elements being referenced by multiple helpers. So one thing we'll expose as an example of a new helper object like that, it's a collection helper, which essentially will let you keep track of a collection of objects and trampoline various functions calls. So you could simply deal with one object, and will multicast all those calls. That's really convenient if you don't want to keep track of a list of stuff in your layout, and, by hand in your code. You could just specify it in your layout file, and that's it. Of course, this is all if you can do that declaratively, but that's a pretty common use case. So one nice examples of the helpers object like that is the idea of decorators. So again, a decorator will allow you to reference multiple views. The idea is that there is a certain class of views, if you want, or stuff that you want to display on screen that essentially wants to be defined in terms of other objects. And right now, that's kind of tricky to do in a nice way. But with the helpers, it's actually pretty straightforward. If I take a basic example of like a Metabolt decorator, we'll see what it does. But essentially, you just get something post layout, get the position of the views that you reference, use the position of those views to do something in your own draw function. So the idea is, if you think about what happens on screen when you want to display stuff on screen, you have a canvas, okay? You will have, sorry, it didn't work. You'll have your image views, and those are normal image views. It's still the good old image views you do know. Here I put some icons, and I'm going to put a decorator to here draw the background. So that seems weird. I mean, after all, image view can definitely do that, having their own background. So why do I do that? Well, because then I can actually modify this background to do something interesting. Here is how it looks. A bit slower. And that's a bit difficult to do if you don't have this concept. So you get where I'm coming through with this kind of examples. That's actually, relatively difficult to do now, but now it's the opposite. It's pretty easy to do with this approach. And that's also very, a lot of new UI or excited designers are coming up with concepts like that are kind of like cross-cutting in terms of the view hierarchies. So now you can actually you have a nice approach to do something like that. And just to show you that not lying, those are the bounds of the views, but you get that.
So the next sort of type of decorator, of helper is a layer. And one of the things that a layer will allow you to do is sort of take a collection of objects and actually manipulate the properties of it dynamically. It also is aware of its bounds and that sort of thing. It'll allow you to support transforms, so you can take that entire layer of widgets and move them across the screen. So what does it kind of look like? So in this case, you just sort of create one. In this particular example, we have a in this particular example, we're going to take a shape object, and we're going to stick it as the background in a layer. And so now that shape object is going to be able to take on the background of that. We've added padding, so what you end up seeing when you add the background is that shape can draw around that collection. Because what I've done is put all 6 of those components into that layer object. But in fact, they are not, it's not nested. It's a flat hierarchy. So you can actually just move those any way you want. They're independently being transformed by the layer code. I mean, that's a silly example, but it kind of proves the point. And when you look at the code that I used to animate it, essentially, all I did was do some silly math and get the layer object and call set rotation and scale X and scale Y on that object. And that's all that was required to do that to this layer. So there are other layers you can do. In this particular case, I made another version that had all the objects fly into the frame. Now, if you think someone asks you to build a fly-in effect, okay, that's going to involve some code and you're trying to figure out how to do all of that, or you're going to try and you'd be able to hopefully find an example, or we can provide an example, or we find a third party of a fly-in type layer and select all the components you want flying in, and they will all fly in for you. So it's fairly easy to build those. And what the helper looks like, again, you just see a list of the components that were in the fly-in. And if it has a background color, you'll give it a black background color. So to kind of show you a little bit of what happens on the inside, essentially what's happening is it's calculating the center point of the view and then animating all the objects to it during the pre-layout, post-layout manipulation. Post-layout, we set all their positions with translate and scale, and then we move them back in. Okay, and that's what it looks like. We call it
and of course, that's a pretty silly example because you can do that relatively easy, this particular effect. But it's more the idea that you can know, you don't have to code those things. You can essentially code it once, encapsulate it into a helper, and then just reuse it.
And we can skip the calculation. So here's another example. This one is a circular reveal. And this one is done a little bit interestingly because you can actually produce a circular reveal which is revealing a bunch of components. Notice there were objects on the screen and mixed with objects that were being revealed at the same time. That you couldn't do with a normal system, but it took a lot of math and a lot of little trickery, but we can encapsulate it, and now you have this sort of useful little tool to work with. And we'll skip how it actually works. So putting that all together in a UI, you can actually, since you can use all of them, you can have that fly in. This is another effect we created. And when you click on it, it revealed that object. So here, see it again. That was a fly in. That's another kind of reveal we built, and that's a circular reveal. And when you look at that graphically, and this is kind of, for me, the important part, that's being done by specifying the different helpers and what are the objects going into each of those helpers, and then having very minimal control of what to do, on click of certain buttons to control that effect. And you'll notice that helpers can be mixed and matched. You could have many of them on one screen. So they're actually providing sort of actions to that layout.
Okay. Yeah, I mean, that's a little bit what we were referencing at the beginning. It's that it's a way of, taking some behavior, encapsulating it, and then just reusing it. It's really about reuse and, kind of sharing code. Yeah. So I guess, like, for the summaries for the helpers, that's what I just said. You can tag your views. A view can be part of multiple helpers. You can encapsulate that behavior like that. It's all declarative, of course, but you could do things a little more, programmatically. But we're really trying to make it nice to be integrated within the tools. So if tomorrow your designer says, "Oh, I actually want a completely crazy effect," well, that would be relatively easy to add. So another example or another category of helpers is, and we hinted at that for a while now about constraint layout, but it's the idea of having virtual layouts. So sure, we want layouts to be flat for various reasons. Performance is one reason, but also power and kind of like the kind of UI you can do if you have a flat hierarchy can be a lot more subtle and a lot more powerful than what you can have if you have to deal with a complex nested hierarchy. So that's kind of a really nice property of constraint layout, and we are trying to leverage that. So the idea of the virtual layout is that we still keep that. We still keep the layout being flat. But sometimes, having something like a linear layout is really handy. Like if I have to define a row of buttons, it's a bit annoying to have to define a chain. I mean, we have tools. It's not, as you saw in the previous talks, it's pretty efficient to do. But, it can be a bit cumbersome. So the idea with a virtual layout like that is to do that via a helper, right? So one of those helpers is a linear helper like that, where essentially it will create a chain. The usage is exactly what we showed before. You just reference the IDs you want, and then that linear object is itself a view. So it will behave like a view. In fact, in the editor, it will behave exactly what you would expect of linear layout. So same ease of use, same easy way to see it, manipulate it, and of course, you can reference other views relative to that one, and it's all pretty straightforward. The only difference is that the semantics are the semantics of chains, which are a bit different than linear layout, but essentially you can do all the typical stuff. Another nice virtual layout that we wanted to add is flow, which essentially give you those kind of flexbox layout-like semantics. So when you have a long list of widgets that you want to, that suddenly are not going to fit, you'd like them to go to the next line, essentially. That's actually not really doable right now with constraint layout. And it's a relatively niche use case, but when that use case happens, it's a bit annoying to have to revert to either run your own layout or to use something else like flexbox layout. So with this implementation, you use it like another helper. And what's nice is because we're still flat, you can also reference objects relative to the individual items that are laid out by this one. So here I have just a silly list of buttons, but that image at the bottom is actually to the left of button 6 and below button 8. And you see that as the screen dimension changes, things are going to reflow correctly. So here it is in video, but you get the idea. It's still a bit early in the implementation, but that should make it in the first release of ConstraintLayout 2.
So one of the other things that we're going to try and build is, we're building, is the management of states. And what does states have to do? Before, we had talked about, and you've probably seen examples where you take two layouts, and then you can use constraint set, and you can switch between them. And that still works, and we'll keep that. That's good. But we wanted a better way to encapsulate that behavior, so you had a sense of, you just took one layout and you set a different state on that layout. So what we did was create this sort of auxiliary file for you that is called state.xml, we call it, in your XML folder. And you can describe two states as two constraint sets using a constraint set description, or two layouts. So you're actually referencing the two layouts that you're going to use. Then on your constraint layout, you can then associate it with that. So here you see set layout description to that layout. And whenever you want to change states, you set state.
So yeah, if you remember, like using constraint sets, a lot of it, it's not that it was super complex, but you had a little bit of initialization to do manually. So here it's just a nicer way of having an XML file specifying those different states, what's associated with those states in terms of the layouts. Just a little easier, and for us in the future, that will allow us to build a nice graphical tool for it.
So one of the things that you can do is add size qualifiers to states. So what that says is, if my size is going to be a difference, I can have one state and have three different layouts for that state, but they're each for different size devices or sized areas. And one of the areas that becomes very important is if you're going to try and use Android on Chromebooks. Because on a Chromebook, you can actually resize the application. When you resize an application on a Chromebook, it's constantly having to adapt. Now, constraint layout is good at that. It helps you with that. But even a constraint layout is sort of limited. And if I go from a little tiny layout to a very, very big layout, I probably want to change my layout considerably. In this particular case, we're going to have a few different states and a default state. And during the on-configuration change, so you can sort of say, I'll take care of configuration change, and during the on-configuration change, you set state and you give it the width and height. And now here you see an example where I'm switching between two different layouts. One is more vertically oriented, one is more horizontally oriented. And it's dynamically switching between them without inflation, without the kind of all the, if you have your hands on all the views, you still have your hands because it's the same views. It just changed layout for you on the fly. So that kind of produces a very helpful effect for you. And one of the things that we do provide also is the ability to add a listener. So on pre-layout change, and you can set begin delayed transition, and then it would animate them. So here in this example, as I'm changing resize, it changed state, and they animated to that change. So I missed it. There you see it changed sizes. So now the cool thing is it's just those 3 or 4 lines of code are giving you this behavior between 3 different types of XML files, 3 different types of layouts. And all the buttons are the same buttons throughout the entire interaction. Okay. So the key things here is it'll centralize the sort of management of those multiple layouts, and we'll provide tooling for that. It'll allow you to initialize it easily, and it provides you with the size qualifiers.
So one thing that we originally did not expect that much, but it turns out that programmers want to program, I guess. So, they wanted a way to manipulate those constraints in constraint layout programmatically. And so we provided an API in 1.0 we call constraint set. That's kind of the same stuff that allows you to do what we just covered, essentially encapsulating an entire state of constraint and letting you manipulate those states, setting those states and having the constraint change, and etc. The problem is sometimes that's not quite what you want to do. Sometimes what you really want to do is just to build a constraint fully on the fly, and you can do that with constraint set. It's just not really meant for it, and essentially you are creating a lot of craft just to do that. Constraint set is really more about I'm encapsulating a state and I'm manipulating and switching states, really. So it was kind of nice to add a little bit of a nicer API there. That's kind of how it looks. It's relatively straightforward. You just create a constraint on a view, and essentially that allows you to set those layout params that right now you have to do by hand. It's not, the best interface to do that. So here, it's just essentially just a nicer API. So a couple more examples, and you see how you can, in a Fluent-like manner, just chain the different calls. Nothing too surprising, but I think in general people will like it. And of course, there is a bunch more stuff that I'm not going to cover, but we'll try to provide a full enough API for you to do interesting stuff. And that kind of brings us to the end of this talk. So if I can summarize a little bit what we are trying to bring with Constraint Layout 2. One, we'll have those virtual layouts, so kind of keep your layout flat, but still have the advantage of having components that you can then manipulate, add stuff on the fly, and etc. We have more helpers with layers, ability of kind of reusing this kind of behaviors, the integration with the tooling, the decorators, the state management, and the live resize, which we think is going to come really handy with devices like Chromebooks and things where suddenly this type of on-the-fly adaptation is a lot more important than it used to be. And finally, this Fluent API. There's a few more things to come. So first of all, thank you. And it's going to be developed a little more at Google I/O in, what, a few weeks?
About 2 weeks.
So the other conferences will start now. So if you want to switch to other conferences, go now. But we will take a couple of questions. So raise your hand, if in case I can see you.
Okay. What did he say?
Yeah.
Yeah, we said good, and nobody expects questions.
Hi, thanks for the presentation. I've messed a bit with constraint layout for the first version, and I noticed a function which is validate on the layout params that is not documented, but if you don't call... They can't hear. Oh. Sorry. Okay, let's try again. You talked about a Fluent API on the layout params, and one thing I have found on the layout params of the current constraint layout is that if you don't do them programmatically, but do not call validate in the end, it does not anything. And this method is not documented. I lost quite a lot of time on this. And,
yeah, that's, I mean, one of the reasons why, if you notice in the new API, you end with apply, is because there was a lot of confusion about what you're supposed to do when if you're directly manipulating layout params. And so because it's sort of a fairly internal API to use that, even though, I mean, people use it. And you don't want to automatically apply it every time you change any one parameter. You want to be able to accumulate it. And we hope that your kind of problem would be eliminated or reduced if someone had a Fluent API. And that's kind of why we built it that way, the new Fluent API. We were experiencing people with your problem. And so we're trying to reduce some of that. So.
Yeah, just to be clear, essentially, we only apply the changes when you call set layout params. So, and you might have to call validate again. I think in the latest version, we do it automatically for you.
Thank you.
Okay. Okay.
Hello. I have one question and one proposition.
Okay.
First, thank you for this very awesome talk. For the question, I didn't really catch the difference between constraint set and constraint state. I think that they do the same thing, but they are not really the same thing. And for the proposition, I think it would be great. I watched the last talk and your talk, and I had an idea. Like, we have the possibility now to have a preview of the content, like, for example, for a list view or a cycle view. It would be awesome if we have the same thing for constraint layout and animation for states, if we can mock events in sample data, like when user, for example, click on this button, we play this animation. And if we could do this in the editor, it would be great. We will not have to run the application and see the animation and come back to the code and make changes. That's it.
Yeah, but thanks for the suggestion. It's it's something that would be pretty cool. It just takes time to do. But for your question on constraint set and the states that we just presented, well, think about it as those state stuff. They are a collection of constraint set, right? So constraint set you can think about it that it's one screen, but here it's like you can define multiple screen. It's a nicer way to load them, all those screens. So it's easier, it's just one line versus having to do it manually. And two, if you have, then you suddenly have this concept of, I just have different state. So if you create, for example, a custom view and that you use the constraint layout to define that custom view, it's super easy to then map that with the internal state of your application. So that's one way. And the second thing is that we can apply those qualifiers, so you can, we can do this kind of automatic behavior as well. So it's more like a convenience. It's not rocket science, but it should be, a bit nicer.
So it does tie together the concepts of constraint sets into sort of more directly into the constraint layout, because you're now able to switch between them by just referencing state, a state ID essentially. The other one, so to make sure you're clear, there's constraint, which is ability to manipulate the params on a single view at a time. And then the constraint set is all the params for all the views within the constraint layout. And then the new state API is a collection of constraint sets which are being manipulated behind the scenes for you. There are actually constraint sets behind the scenes.
And that's kind of why, like, using constraint set to define constraint on the fly for one view was not exactly optimal, because essentially you are saying, I'm taking the entire state of every view in my layout, modifying one view, and then apply that, and we reapply to everything. So that's not great, right? Which is why the new Fluent API lets you to do just one view and do it right.
Okay. Okay, go ahead.
First, thanks for the talk. It was really awesome. And then I have a question related to performances on Constraint Layout 1.1. In the last two beta, I saw questions around on Reddit and on Stack Overflow related to the on-measure issues, and looks like it was okay, we are going to do a flat hierarchy, that's awesome, but at the end of the story, if this is less performant, then relative layout is going to be a pain. I was wondering if you have updates on this related to the release version, and that's so
good question, because So just to try to keep a simple answer, because I think we are getting kicked out soon, but essentially, in terms of performances, should be about the same as relative layout for the same situations. But of course, constraint layout can do a lot more. It turns out that actually we've got some issues with chains. So if you use chains a lot, particularly if you mix them with a match constraint element, it turned out that it's a little slower than what we realized with 1.1. So probably expect a 1.1.1 soon, because I looked a little into it and it's like, yeah, we can do a little better. I was a little surprised by the level of complexity that some people do with constraint layout. Yeah, I have 60 views and somehow it's slow. Well, yeah. So, but the nice thing in general is because it's a support lib, we can do releases as we go, and now we have a pretty nice architecture to optimize stuff, as I talked a little bit today. So I think we'll get back to where we want. But in terms of performances, we should be a little faster than 1.0, for instance.
Thank you very much.
Okay.
Thank you, and we'll probably stick around a little bit if you want to ask us questions, and of course we'll be here tomorrow as well. So don't hesitate to grab us in the corridor.
Yes.
We are here for that.
Talk.